Good morning. My name is Rupesh Warrior, and I'm going to be talking about the big data platform, the central big data platform that Symantec built over the past few months, and the lessons that we have learned as we went along that journey and built the big data platform. And essentially, the core idea over here is that we want to share the aspects that we learned, such that anyone who is going through that journey or who is planning to go through that journey can essentially use these lessons that we have learned, anything that we can share, use that for sort of jump-starting their journey as such. So first thing I want to mention is when I start to talk about Symantec and big data, there is inevitably a question mark in people's face, thinking, Symantec is more about security. What are you guys really doing about big data? Symantec at its core is a big data company. We analyze on a regular basis petabytes of data so that we can provide our customers with true zero-day threat protection, right, and the best-of-breed security. We have multiple product portfolios that you guys are aware of, be it Norton, be it SEP. There is data leakage prevention. There is net backup. There is the CA VeriSign business that we have. All of these different businesses tap into all the metadata that we collect from our customers and use that to provide the features and the best customer experience itself. So I want to specifically talk about the organization and give you a bit of clarity on the organization that I represent within Symantec. It's called Cloud Platform Engineering. And the core charter of this organization is to build a consolidated cloud infrastructure such that the product teams within Symantec can do what they do best, which is innovate, right? So they can focus on the innovation part, but at the same time, they can look at us, as in the CPE organization that I represent, to essentially provide them with a secure, a multi-tenant, and a scalable platform. So that's the charter of this organization that I represent. I already talked about specifically some of the workflows that we have, which is on the analytics space. There is also managed security services that we provide for customers, as well as enterprise. And we also analyze the logs that we collect from our appliance business. So we use that, again, to provide a great customer experience, because we try to understand how the customer is actually using the product and provide them with support based on whatever their use cases are. So I want to touch a bit on the architecture that we put together when we started this journey of the cloud platform engineering. So one of the core principles that we used was based on the OpenStack philosophy. What do I mean by that? Well, we wanted to build these services in sort of a federated model, such that each of these services that's shown up here can be a standalone service. But at the same time, our customers, which specifically are other Symantec product organizations itself, they will be able to mix and match whichever services that they want to use for building whatever applications that they need. Now, I want to also tie back into how this is relevant to you guys, in that specifically I'm going to be focusing on one of the service, the batch analytics service in there, which is specific to the batch processing and the interactive query use cases that we found within the organization. So that's the area that I'm going to focus on and provide you with sort of the lessons that we learned while we were building that particular platform. Now, just to go back to the architecture itself, on the left side, you see these supporting services. So one of the other aspects that we decided was that this is going to be a generic central platform for all of Symantec. And all services are going to run on this, which means that we wanted to build supporting services which was common for all the different services that we were going to provide to our customers, right? Aspects like deployment, automation, orchestration, logging, monitoring, metering. So these are frameworks that we are building such that all the services will be able to utilize them. And this not only provides our operational team with one single way in which they want to be able to interact with our services and manage them, but also reduces the time frame for us to bring up a service. Because when we bring up a service, well, you don't have to learn a new stack, new kind of logging, monitoring, metering service, or management, whatever technology that is there. You're plugged into whatever framework that we already have in place. And it also provides the scalability that we needed. So on the right-hand side, I also want to call your attention towards the identity access, because what we decided was we want to have a central authentication system, and we selected Keystone, which is the authentication system of OpenStack itself, to be our central authentication system for the batch processing and all the other use cases that we have. So given that's the sort of background that is there, I want to now talk about the platform objectives that we defined as we started to build the big data platform. So I had mentioned to you that we decided to have a central platform. Now, what does that really mean, central big data platform? Now, I'm going to step away from the overall cloud platform engineering and focus specifically on the big data platform. And what does that really mean? This means that, as I said, a lot of the supporting services are the same, but also that provides our customers with, let's say, the audit customers, as in, again, Symantec organization, with audit and compliance and security aspects that is central to the whole platform. The other aspect is that there is seamless integration that is there across all the services that we talked about before, that is within the cloud platform engineering portfolio. One thing we also wanted to do when we built the big data platform was we talked to our customers and understood that there are two different kind of workloads that they needed. One is batch processing, which is, you can think of the heavy MapReduce workloads that they have, which are typical applications. And then they also have queries which run across multiple years worth of data. So that's the batch processing side. Then there is also the interactive SQL, which is more of a needle in a haystack kind of workflow, right? Where response folks want to have one particular row that they want to pick out based on any question that they want to answer. So when we are building this big data platform, that was two use cases that we knew we needed to support. And I talked about the security aspects itself, which was core to our sort of principle of our platform. But at the same time, we also wanted to make sure that we are providing resource tenancy from the multi-tenancy perspective. What do I mean by resource tenancy? So when you think about traditional big data platforms that have been available, be it the MPPs, be it any other platforms that have been in the play in the past, resource tenancy is not something that was well done. So in one of the specific use cases that we have an legacy system where one user can pretty much bring the entire cluster down. So that was one of the core principles that we had when we were building our service, was that it has to be supporting resource tenancy. From the reliability perspective itself, we wanted to make sure that we are taking all aspects as something that can fail. We assumed everything can fail. Basically, it means that a node can fail, switch can fail, rack can fail, even a cluster can fail. Finally, even a data center can fail. So what we wanted to do was we wanted to basically make it active-active, which means that if one data center goes down, still the workloads can seamlessly migrate over to another data center, and that we would be able to continue servicing our batch analytics to our end customers. Also, part of that is self-healing, right? So if you have one particular data center go down, still your jobs are going to work. How does this actually reflect on the architecture side? Well, from the architecture perspective, you want to make sure that you are, in our particular case, you have to ingest the data into 2 different data centers. And so when our customer sends us some file and we say, yeah, it's done, it basically means that we have ingested that data into 2 different data centers. So that's how it actually reflects on your central architecture. The other aspect is when you are doing active in 2 different data centers, think of the CapEx that you're spending on the amount of infrastructure that you have, because you need to have a replica, right? So then you want to make sure that you are utilizing those resources in a right manner. You just don't want to throw in a complete replica of your production on another data center and say, it's okay, we'll just leave it there until data center 1 goes down. So being able to understand how the workloads are happening, how the resource utilization is happening, and based on it, being able to adjust the workload was another aspect that we wanted to make sure we are providing. And last but not the least, absolutely, is the performance aspect, because we wanted to make sure that we are performant. And one aspect that I did not touch base on in the previous slide, because I wanted to make sure that I get to the objectives, is when we were building this overall services, the core idea is that we are building all of this as a service through a REST API. So our customers can submit jobs into our platform through a REST API and ingest data through that REST API. And similarly, they will be accessing all the other services also through the REST API. So that's one of the core principles that we also had. Now to specifically get into discussion about the decision criteria, how did we go about in our distro selection, in our hardware selection, and what were the lessons that we particularly learned from it, right? I want to jump into that aspect. So when we started to look at the multiple distros, so I'm going to talk about hardware right after this, but let me focus on the distro aspect itself. So when we started to look at the multiple distros, based on all the data that we had, all the use cases that we collected from our customers, we understood that our Hadoop was going to be in the mix. So it was that just fit the batch processing use case so well that Hadoop had to be the answer. So we went ahead with the distro selection, and we realized that majority of the distros are pretty much the same underneath in some of the core pieces. For example, HDFS is HDFS is HDFS, right? So there is no difference over there. So what we wanted to look at and focus our time on was what are the core value additions that these different distros bring into the picture. And management was definitely a key piece. Now, I've already told you that we were building our own sort of management framework, the deployment, automation, orchestration, and a lot of other companies pretty much the leaders in the market that you would hear about, eBay, LinkedIn, all of these guys have gone ahead and done their own version of the framework. But what we wanted to do was make sure that whatever framework we build is lightweight and that it can integrate with the features that are already present in the distro itself. So in aspects like deployment, how does deployment work? How does upgrade work? Is rolling upgrade supported? Or how are nodes added and deleted, right? How is the monitoring actually working? Are there logs that are getting shipped? Can we redirect that to our logging, monitoring, and metering framework? So these were fundamental aspects that we were looking at as we looked at the management piece. Now, the other aspect is about the multiple workloads itself, because as we were going through our use cases, we understood that we have a lot of legacy applications that need to be moved over into this central big data platform, right? So this means that think about the technology stack, and we had it in the mix, right? All the way from Microsoft SQL to Vertica to all sorts of different solutions, right? So there was a lot of applications that have already been written, and we needed to move it over. And that meant that there was tons and tons of code, be it a lot of them were SQL code. Now, how do we migrate that over? And we wanted to make sure that whatever distro we select reduce the amount of pain that we would have in doing that migration, right? So that was one thing. The other aspect was also we looked at open source tools, as far as the performance testing goes, be it Presto, Shark, all of these were aspects we looked at to make sure that whatever be the right kind of tool which fit our use case was the one that we were going to go ahead with. So those were aspects that we looked at, and how they integrated with this distro. So that's another aspect we looked at. Then security. Security is, for Symantec, is not an afterthought. In the Hadoop world, as we started to go through our journey, we quickly realized that security was sort of not the fundamental pieces in a lot of the companies. But for us, when we started off in the distro selection itself, security was one of the core pieces that we wanted to build, because going back to the core principles that I talked about, right? Scalability, security, multi-tenancy. These were the three principles that we had as we built our platform. So security was definitely not an afterthought. And the other aspect is about scalability, which is what kind of file formats did a particular distro select, right? Or rather, a distro provide support for. ORC, Parquet, or did they have their own proprietary file format that they needed for good performance? And if they had a proprietary format, then how would we actually move from that proprietary format into a different format in the future if we needed to do that? So these were also considerations that we were thinking about. The next piece was about reliability and self-healing, which is, as I mentioned, we wanted to make sure that there are no single points of failure. So the HA features that have come about with 2.1 were absolutely the right timing for us, and helped us in making in our life much more easier in making the distro selection. As well as how does, from the operational management itself, are there ways in which you can do job submissions? Is there ways in which you can manage the data ingestion itself? So those were core pieces that we were thinking about from the operational aspects. So what we did was then essentially took all of these sort of areas we wanted to focus on, and we built a 1 petabyte cluster. This was a test cluster that we built in one of our data centers, and essentially built, or rather put in multiple vendors into the mix, and took the same workloads that we got from our customers. Basically, we landed up porting over some workloads that they had, and ran the same workloads across these vendors that we had ultimately trimmed down to. And a couple of different tests that we did. We obviously did the performance testing to figure how the queries ran between the different distros. But at the same time, we also did testing from the hardware profiling, and we also did the testing from the network capacity, right? In Symantec, we traditionally call it the east-west test versus the north-south test. What it means is inter-rack as well as intra-rack. So north-south stands for intra-rack, east-west means inter-rack. So we wanted to figure what is our architecture going to be? How much capacity do we need to our spine itself? So these were aspects that we looked at as we ran our workloads. And this will vary from company to company, right, depending on your workloads. For us, we understood quickly that our workloads were going to be CPU bound. And based on when we maxed out our CPU, or rather we extrapolated to see what it'll look like when we max out our CPU, we understood that we need a 40 gig connectivity into the spine itself. As well as we looked at the disk capacity that we needed, and we landed up on a sweet spot that we selected, which is 12 spindles, 4 terabytes. So that's the node configuration that we went with. I'll also get into the details about the hardware specifically in a later slide, and you guys can also ask me more questions, and Srinivas at the end of the session. The other aspect is we also use nearline SAS during this test. And the reason I mention that particularly is because after the test, we realized that we do not need nearline SAS, that we are pretty well off with SATA. So those were other aspects that we used when we did the selection. So these, just to point out that the name nodes and the client nodes were located at one particular location. Now, what we did was, based on all the tests that we did, we looked at the customer use cases itself. We said, okay, here are all the aspects that we want to test, and we tied it to all the customer use cases that we had and said, how do we want to figure out which distro to make? And we inevitably came back with the answer, well, you need to have some sort of a weighting, because some decisions were more important to us than others. And that helped us sort of also evaluate the different decisions and the trade-offs we were making. So for everyone, including the XX, it was very clear that while we go through this metrics, if you are going to select one particular distro, then what does that mean? What trade-offs am I making? Because there is a clear apple-to-apple comparison over here, right? So we went ahead, we did this weighted metrics, which helped us sort of figure out which distro we wanted to do, or rather we wanted to select. So that helped us decide our hardware as well as the distro, and we moved forward on doing the platform development itself. And what I want to specifically share is the key lessons that we learned as we went through this journey. So the first and foremost aspect that we learned was to make sure that you define your platform objectives upfront. So if you're going through this journey, make sure that you understand what you're building this platform for. For us, we had, you can think of it like an 80-20. We had 80% of our objectives defined, 20% of them were still not clear to us. As we went through the journey, we learned quite a bit. We came back and we had to refine some of the objectives itself, which meant that some of the tests had to be redone. So make sure that you completely define your objectives as clearly as possible, such that you can do the right kind of testing. Not only right kind of testing, it will eliminate the amount of due diligence that you would have to do. Let's say that you need to have POSIX file compliance, or you need the NFS mount. You need that for whatever reason. That trims down the amount of distro selection that you need to do significantly, right? So make sure you understand your use cases very, very well, and based on it, come up with the exact criteria and the objective that you need. Because that'll help you, sit in a room and come out with maybe 2 or 3, different aspects that you need to test. Then make sure that you don't agonize over your hardware, because this is one area we spent a lot of time on. We landed up thinking about SAS versus nearline SAS versus SATA. At the end of the day, our final configuration turned out to be more or less what the vendors had been suggesting to us from the beginning itself. Yeah, there were a few fine tunings that we did, but it was, for our use cases, it was fine. So the primary reason I'm mentioning it is because we spent a lot of due diligence in there and time in there, whereas you could go ahead with just the mainstream, and you're not going to get it wrong, because you're going to scale out, whatever be the case. So make sure that you are not going for any custom architecture on your hardware. Just go mainstream. That helps you. For us, as I mentioned, we went with 12 spindles and 48 terabytes per node. On the data node sizing itself, what we did was we looked at the sweet spot, from the capacity versus cost. Those are other, and it'll change with time again, because a year back it would have been 3 terabyte, now it is more 4 terabyte. So you just need to know where the sweet spot is based on whatever investment you want to make, and you will be able to make that selection. Now, the CPU to disk ratio is also absolutely important based on what is your use case again. For us, we went with a 2 to 3 ratio, and we have 16 cores, so it's basically 32 cores with hyper-threading. So that's the ratio that we went ahead with. Again, it depends on your use case, what exactly you need. Finally, on the RAM and the SKU. So I want to make sure this is very clear to everyone that we made a fundamental decision, which is make all the SKUs uniform. This helped our operational team tremendously, because when you're thinking about replacing a particular node, you don't have to think a lot about what is the configuration of this node, how do I replace it? It's all the same. It's just a brick, right? So all the way from procurement to operations, and if you need some additional pieces that you put on the side for a rainy day, those are the same bricks again, right? That you can use it for the name node or the data node, whichever nodes that you want. So one aspect which got changed because of that decision was our RAM. So our RAM, we landed up over-provisioning it slightly for 2 reasons. One, it could switch between the name node and the data node, whatever be the need. But also, we wanted to make sure that we are looking into the future. So make sure you're thinking not only about your use cases, but how far future are you looking at? Because the basic idea over here is that Hadoop is going to get optimized, and which means that we are going to move more away from CPU bound to more memory bound. So the workloads being real time and all of those, our assumption is in a few years we are going to be doing more real time use cases as opposed to batch processing itself. And even if it is batch processing, the need for doing really fast queries is going to be there. So RAM is going to be required more. So that's why we went with the 128 gig. And then make sure that you are looking at what are the core principles within your organization about open source versus proprietary. Because that, again, helps you make a fundamental decision of which way do you want to go, right? Make sure that you are also thinking about the investment. So open source is definitely comes with a cost, right? You get what you pay for, right? So make sure that your company and your organization is ready to invest. If you think you want to be self-sufficient, well, there is the cost attached to it. So make sure that you're ready for that. Also, how much is your organization's appetite to take cutting-edge technology versus open source technology, right? Because if you don't have a huge operations team, you want to make sure that you're more mainstream, that you don't want to be doing a heck of a lot of testing of your workloads, that you want something that pretty much has been tested out there, has been proved out there. Well, that again provides you with an answer and helps you trim down the amount of selections or due diligence that you have to go through. The other aspect is to, I mentioned already about features and support use cases that make sure that you understand your use cases very well, because that helps you figure out which distro you want to go with. On the management side, as I mentioned, again, you want to look at what is the kind of management tool that you want. Going back to it, either you're building your own framework or you're going to go with one of the management frameworks that come with the distro itself, be it Ambari, be it Cloud Manager, whichever ones that you're going to use. Make sure you understand which way you're going to go, because that will inevitably help you in the testing that you're doing. The other aspects that I talked about on the security point of view, you need to make sure you understand that and how important is security for your needs, because there are a lot of tools out there. For an enterprise which does not have that level of lockdown on security needs, you might be able to use more open source tools. Like Netflix has Genie as one of the management tools that they have open sourced. Security is one of the fundamental pieces that they haven't done, because Netflix, frankly, for them, security was not a major important criteria. So they have basic security, but nothing huge over there. So that could be something that you just take off the shelf, right? So you need to figure, again, what's your appetite for security? What are your compliance requirements? Because for us, we had, as I mentioned, managed security service is something that we have, where we land up getting tons of enterprise data, and where the expectation of our customers is that we have core multi-tenancy. So that means that security has to be built from ground up, right? So that's one aspect that you need to make sure. And then going back to it, open source itself, if you're going ahead with open source, make sure that you are investing in whatever customizations you would need, because inevitably open source has some sort of gaps. It's a generic, whichever tool you pick from open source, it was made for a generic purpose. It will not fit all the needs that you have. So you would need to have the expertise in-house to be able to go ahead and make those changes. Now, I talked about the technology part itself. There are also business drivers that you need to be very well aware of, which is strategic partnerships, as well as OEM deals that you probably have in the pipeline. And those can also be drivers. Another aspect I want to quickly mention is about the cost. So the cost itself, we did a 2-year TCO initially, and one of our executives told us, maybe you want to look at a 5-year TCO, and let's do that projection. When we did that, we had a huge lesson, which was there is a remarkable change on a 2-year versus a 5-year. Be it from the support perspective, be it the licensing perspective, be it if you're going to invest in within the company and grow an open source team, well, that's a cost too. So somewhere in there, you're going to see a hockey stick. Now, for that, to see that hockey stick and how that comes out, you need to be projecting for a longer time. So at the beginning, we were skeptical about why we are doing a 5-year TCO, but it really helped us get some insights into bracing ourselves for some of the costs that will be coming in the future. And we used the metrics-driven selection, as you guys saw, which really helped us in figuring out what are the trade-offs that we are making. Finally, when you're building a platform itself, you need to make sure that you are thinking about driving adoption, right? This is purely for folks who are building platform as a service within their organization. Because think of it like a product that you're selling, which means that your customers need to have the level of documentation that they need. They need to be able to get trained so that they can go over the hump of this concern that they have about the new technology or the apprehension of a new technology. And one of the ways that we solved it was we built reference application, which mimicked some of the use cases that they have. So when they looked at the reference application, they were more like, it makes sense. Okay, this is not too bad. I can start to play with it, kind of thing. So the adoption was, definitely went up after we were able to build those. And if you have one takeaway from this particular talk, it is that big data, building a big data platform, you can see it as a glass that is half empty or half full, right? Because you're going to have challenges. From the challenge perspective itself, if you're going with any open source or any of the Hadoop distro aspect, brace yourself for the development work that the team has to do, the gaps that you need to fill. And also brace yourself for the DevOps mindset, because gone are the days when you do the development, you throw it over the wall, and you hope that the operations team is going to handle it, right? When you're doing the development, you have to think about the operational ease or the operational management fundamentally from the core. So that is a mind shift that a lot of teams have to go through, team members have to go through. So make sure that you're thinking in that manner. And that means that it is going to be a cultural change within the organization, not only for the platform team itself, but for the users also. Because there are new technologies, they have to start thinking in different manner about how they build the application. Now you're starting to talk about building an application that will traverse multiple data centers, and it has reliability in that manner. So how do I write that application such that it's actually getting, the workload is seamlessly migrating and taking advantage of the infrastructure itself. So those mindset have to, and cultural change has to come into play. And as with all challenges, on the other side of the coin is the benefit, the business benefits that you get. We landed up gaining a lot of financial benefits, as well as new product lines that we were able to build because of the amount of insights that we got. And I'm specifically talking about big data platforms that we have built in the past, where Symantec actually has the largest known security metadata store that we built. And a lot of different teams came into the picture with bringing along with them that data feeds, which helped them sort of gain insights from each other and starting to build security applications, which as siloed groups, they never were able to get that level of insights. So your organization, whatever it be, is going to gain that level of insight and is going to get those business benefits, but they will have to invest in it to get those benefits. Finally, start experimentation, because a lot of companies sit and talk about doing a big data platform, and they just agonize over it, right, as to how much time it is going to take and whatnot, and how hard the technology stack is going to be. And 1 month later, they meet again. Well, the technology stack has changed by that time. Right now, you go back to the table. So just start the experimentation and learn from it. And above all, have fun. So I want to leave you guys with one final thought that one of our executives shared with us, which is, and this struck a chord with our team as we are going through the journey of platform development, which is, and we are still going through it, is that if everything seems to be under control, you're definitely not going fast enough, right? And that is something that anyone who has done a platform development can relate to. So one thing I do want to mention is that Symantec is definitely hiring quite a bit on both OpenStack as well as on the big data side. We actually even have a booth in here where our HRs are, folks are there. So make sure you stop by, and if you have any Q&A, now is the time. So Takesha, if you can help.
I'm coming.
Yeah, over there. Srinivas, you want to come?
Yeah, but you said one of the early requirements was having a REST API on top of your platform. And so I was wondering, when you did that, did you lean towards having like a consistent but proprietary API on top of your platform, or did you go towards having a, exposing whatever APIs happen to be in the products you built your platform from, or did you find a balance in between, and how did you make those decisions?
All right. So do you want to take that?
Yeah, sure. So basically our design philosophy is we don't want to invent yet another layer on top of Hadoop. So we were exposing as much as possible the underneath APIs through the platform. So wherever we have gaps, especially in the areas where we want to provide integrated secure tenancy and so forth, wherever we have gaps, we bridge those gaps by augmenting the additional API layer on top of it.
So question is related to the security. Now, what kind of security you have on your cluster related to authentication, encryption at rest, or data in motion?
Right. So basically what we have in place today is the underlying, you have the authentication system, as I mentioned, the OpenStack integration. We also have the Kerberos integration, as well as we also have compliance requirements that we need to meet for different kind of data that we typically tend to harbor, right? Be it PII, PCI. So all of those come with different SOCs. All of this come with different kind of compliance requirements. So based on that, that, some of them have to be in physically caged areas itself. So depending on the use cases, depending on the security needs itself, our security profile is dependent on the use case. Could you repeat that? Sorry.
Encryption is also there on your server.
Okay. So right now we essentially are using Kerberos underneath, and we use LDAP and Keystone for the authentication, so that we can retrieve all the data that we require for the multi-tenancy implementation.
Hey, you talked about network very briefly. Would you be able to give us an idea about what your criteria were to select the top of the rack switch and the spine switch in particular?
Okay. So regarding the network selection itself.
Yeah, so basically the network selection is based on our data, experimentation with the queries and so forth. So what we have done is when we ran the tests, we figured out when we max out the CPU, keep the machines completely busy. So we measured what is the traffic that's going across, for example, let's say between map and reduce phases through the shuffle. Measured how much amount of throughput we need and how much it is going within the rack and then across the racks. So based on that, we figured out in our cluster roughly like 140 gig rack to spine is good enough, and within the rack we have non-blocking NIC level 10 GBS switch. Yeah, right now it's 140. Yeah.
Thank you, Takisha.